Welcome, everyone. Thank you so much for joining us today. Welcome to Office Hours. This is a program where we invite luminaries from the software world to share insights. These are one-on-one sessions with experts, and they've been a huge success. I'm Lauren Demuse, partner and COO at Theory Ventures, and I'm delighted to introduce our discussion today. We'll chat in the fireside format for about 40 minutes, and please feel free to ask questions within the chat box, and we'll see if we can intersperse them in. To begin, Tom Tunguz is the general partner at Theory Ventures, our $230 million fund, focused on companies leveraging technical discontinuities into go-to-market advantages. And prior to founding Theory, Tom spent 14 years at Breadpoint as a general partner, where he made investments such as Arbitrum, Mysten, and many others in the space. We're joined by Evan Cheng, founder and CEO of Mysten and creator of SUI. Evan has constantly tackled some of the hardest challenges in the organizations he's joined, from the systems that are the hairiest, messiest, need to be rebuilt, that no one wants to tackle, from Apple to Facebook, of course, now Meta, and now in the realm of blockchains. His Web3 work has led to dramatic improvements in performance and usability with the Move language and VMs as the basis of the smart contract layer, as well as DAGs. And just as a data point, Mysten's token, SUI, is worth $16 billion, with users unlocking $600 million of value, which is up 3x this year alone. So today we'll have a chance to probe these experiences. And with that, I'll hand it over to Tom.
Thanks, Lauren. Evan, such a pleasure having you on the show. Really appreciate you coming.
Hey, looking forward to this. Thanks for having me.
One of the things that really stood out when we first met, and I remember we went for a walk in San Mateo, was some of the challenges that you've had in your career and your ability to take and solve really difficult technical problems. In fact, I think of any of the founders that I've met, that pattern just repeated itself over and over again, from hardware to software. And would love for you to share a bit with the audience about the systems that you and the team were designing at Meta and how that led to the creation of Mysten.
Yeah, so my team were some of the earliest member of the Libra/DM project. It was a blank slate project, like the one I love to do. The challenge was simple. How do you build the payment rail for the future for billions of users, right? Which Facebook has massive scale, and the ambition even go beyond that. So the things we're looking at is, one is scale. The scale is massive. The other part probably is even more challenging is how do you ensure the safety and correctness of every transaction, every program that runs on this platform. So that immediately led to a lot of debates around what the smart contract language should look like, which led to the exploration, the design and implementation of Move. And then Move Prover, which is, before we left, we were able to use that to basically run continuous verification of the core of the DM project, which is basically unheard of in the industry. So that plus all the other regulatory constraints that we were facing with a lot of the other issues of chain protocol, how to deal with this sort of thing, the schema, everything. And it was a fun challenge. Building a blockchains for that kind of scale was definitely the kind of work that we all loved. And so as we build it and we evolve the system, as we try to build more application that were not obvious at first, what kind of challenge we're going to run into, we start learning about the limitation of the blockchain architecture in general, right? All the blockchain look more or less alike to that point, including DM. And we learned about the constraints it will on-chain storage will have, how many things that can be there outstanding. We learned about accessibility concern. Turns out transfer value from one account to another account is only a small part of a payment system, right? How do you get payment into the hand of millions and tens of millions of users like that? So all that led us to like regroup and thought about, it's like, okay, if we want to build something that's a platform, that's even more general purpose than DM, what will it look like? Having all the learnings that we are already, or the experience we already had, thinking in terms of first principle from the end product, what the end result will look like, and then think about what the developer experience is going to look like, the user experience is going to look like. And we Mysten led to the design of SUI.
Maybe we can start with a language. So about 25,000, roughly 15 to 25,000 software engineers in Web3, depending on whose survey you count. Well, you have had some previous languages within the ecosystem. Those languages are bespoke to the ecosystem. In other words, they don't exist really anywhere else, maybe aside from Rust. Move is a language and a virtual machine that has a bunch of special characteristics, and you touched on that too a little bit. Maybe we can spend a couple minutes here talking about why did you choose to develop a language? What does it mean for formal verification, and how does Move allow more software engineers to come into the Web3 ecosystem?
Yeah. So first you have to define what the requirement for this language. What is a smart contract about? It's about managing asset, fundamentally. The logic about the asset, updating the states of the asset, transfer assets, automate a lot of the kind of rules around the transfer or how they're being used, access control, all that. And fundamentally, this has to be something also statically verifiable, and that's a critical requirement. And you want to take away a lot of the constraints and the difficulty with for general purpose programmer to come in and be able to quickly ramp up, lower the very, very steep learning curve in general with your smart contract.
Static verifiability, what does that mean?
So you have to be able to mathematically prove ahead of time before you deploy the software that is doing exactly what you intended to do. And that is a hard challenge in software. Verification is very hard to do. People are probably more familiar, software developers are more familiar with testing, right? You use unit testing, you do system level testing, integration, you do fuzzing, you stress test it. But even those are not enough to say, I can say with near 100% or 100% certainty, under no condition, this can behave in ways that's a surprise to us. When you're thinking about the ultimate goal of a blockchain or smart contract is to managing billions or trillions of dollars worth of asset, mistakes are not acceptable, period.
I think the only other place I've heard of formal verification being deployed is a space shuttle, right? Or rocketry, where...
Well, some of the most mission critical protocol have gone through this kind of level of proving. There's a lot of different kind of verification mechanism or systems out there. I'm definitely not the expert, but yeah, imagine if TCP/IP it has some kind of incorrectness in that can be exploited. Imagine the internet routing protocol has bugs in that cannot be proven correct. Imagine all the protocol the web browsing uses, all that. Imagine how unacceptable that would be. Now think about something that potentially, if it goes wrong, we're talking about massive catastrophic financial losses. That's the level that's a hard requirement.
Right. And that we've seen that, right? We've seen the hacks across the bridges, and I think it was like 2021, there was 3 or 4 billion lost. And the idea with formal verification is, like you said, you can prove a priori that those kinds of things won't happen. And that's baked into the language, it's baked into the blockchain.
Yeah, and that's a level of that's a safety or correctness requirement we're talking about here. Yeah. So coming back to Move, once you understand these requirements and you quickly understand, okay, Solidity doesn't fit the bill and it doesn't meet many of these absolute requirements. Once you have the dynamic behavior, you lost the battle already, and you're never going to get to that level of certainty or correctness. You understand a lot of things that the Solidity exposed developer to adds a lot of kind of burden on them. They basically have to be security engineers. In addition to be able to understand the logic and design of their smart contract, they have to think about all the possible ways that reentrancy can happen. Ownership check that's not being done or being one line is a mistake and your codes are out there, somebody at some point in time, a hacker can find it and exploit it. Some of the most popular Solidity contracts I still have incorrectness in them, and they're still being found by white hat hackers, right? That's great. You're racing against the black hats. That's just scary, right? Unless you have that level of certainty, you're not ever going to meet the minimum product requirement to be a smart contract language. We quickly realize you can't use Solidity or some of the esoteric kind of languages out there. They're all missing some requirements. And then we thought about using Rust because the linear type is great for modeling asset ownership. The borrow semantics is great. But then using Rust is not right either because you also need metering, right? You also need to be able to have runtime verification to protect against some of the common mistakes. A lot of these requirements, you take a general purpose language, you can probably strip it down to some subset / superset, adding some other features, and then all the benefit you get from the existing tooling goes from the window, and it becomes a monster. It's too big, right? And you want something that's light. You also want something that can be, it's really a sort of basis that you can build other sorts of language on top of if you need to. So a lot of these requirements led to the understanding is that, okay, we're going to have to build our own, design our own programming language for this, for Libra. I was still called Libra at the time. I prefer the name Libra, and that led to the development of Move.
And how have you found the developer response to this new language? Often it can be exciting to start a new language, but you also have to learn it.
Yeah, I think initially there's sort of apprehension for a lot of the people maybe outside the industry. It's programming language is not for everyone, right? It's a sort of a field in computer science most people don't study these days. And so a lot of people don't really understand the need for it. But once people come around to the ideas of the necessity of it, and they touch upon the language, once they hump off the bar, then the things changes really quickly. What we're seeing is once you get over the initial hump, the learning curve is much, much lower than, say, Solidity, and productivity is great. We have people say this is clearly 10x or whatever better, because you don't have to worry about a lot of things you have to worry about. And then just purely from productivity point of view, getting a lot of people excited. Now you're seeing the ecosystem really taking off. It's not just SUIs, but other blockchain have adopted Move, and there's definitely a growing kind of a population, a base of developer that's now fluent in Move. So that's all great. It is definitely growing.
Yeah, there's no doubt about it. We hear a lot about Move as both the language and the EVM as being, especially if you're coming from the Web2 programming language, much more approachable than Solidity because of what you said. It abstracts out a lot of the complexity, and if a developer has confidence that they can't make a catastrophic mistake in moving assets, there's there's a lot of value to that being built into the language itself.
Yeah.
And then, so on top of the language and the virtual machine, you started to release some interesting advances, right? I think the first one we were talking about before was ZK login, using zero knowledge proof for the login. Can we talk a bit about that? What was the motivation behind that? What's the advantage to having a zero knowledge login?
Taking a step back, right? So if you think about a value of a blockchain as a platform, one of the most important thing is how do you get people onboarded and using any kind of product, any application using a blockchain? The model of having to connect your wallet and having to safeguard your seed phrases, this is maybe okay for crypto native people who owns a lot of assets. They want to manage themselves. But a lot of sort of more consumer product type applications, that's not acceptable trade-off. People describe to me is like to play a game, they have to figure out which of the wallet works, and then you have to be on the TV screen using the terrible virtual keyboard and try to connect your wallet. And then you realize, oh, by the way, I cannot actually have to acquire these tokens to pay for gas to be able to get started. Anybody who's built product before knows any kind of friction in onboarding user, it's terrible. You're going to lose 99% of your customers right there. But on the other hand, a lot of other solutions, this is very common in the history of technology or internet, is that if your decentralized applications or technology is hard to use, you go back to a centralized kind of solution. So you have a lot of solution out there. There's third party doing some of the custody your key, facilitate that onboarding experiences step forward, but you go back to centralization. That means you add risk of centralization, you add friction, you add all the other bad things with it. So ZK logging was basically this like on-chain, like a building protocol at the SUI level that anybody can adopt, and you can have all the benefit of social logging, like you can log in with your Google account or Apple ID and all that, and without all the downside of a centralized solution. There's no one custodying your key. There's no linkage between your social logging and your on-chain identity. It's also almost like magical, the best of the worlds, right? But the reason why we do that is all about, okay, let's solve one part of the problem, the onboarding problem, the friction, removing the friction. So in conjunction to ZK logging, we had building to SUI to be able to do sponsored transaction. And this is very different from, say, Ethereum. They have a gas station type, which you have to program it in. This is more of application level. Say, okay, if I at application level, you can choose to say, I want to use a sponsored transaction to pay for gas. So the consumer never exposed to it. And this is important, right? Because then you can do things like other way to pay for gas. You front the cost, or you ask the user to do something to generate a fee to pay for gas. So these two combined solve a lot of the onboarding problem, and we're getting great response from that.
That's phenomenal. Yeah, I remember, going into Coinbase my first time several years ago, and being able to figure out how to fund from fiat currency into a Coinbase wallet, and then started to get deeper and deeper into these Telegram crypto groups, and I started to go into other chains and figuring out, okay, I need a new wallet, and then in order to actually transact on this chain, I need to fund the wallet first.
Yeah.
Getting that to go the first time, I don't know how many sets of 12-word passphrases I had, and figuring out this wallet versus that wallet, whether it was like a custodial or non-custodial wallet, on which chains were they compatible. Phantom was only compatible on a handful of chains, and then Terra had its own. So it's really wonderful. I think that the blockchains themselves, and particularly Mysten, is looking to solve a lot of these onboarding problems, because as you said, and I'm sure from your Facebook or your Meta days, any friction in that initial onboarding flow just crushes the yield.
Exactly.
It. So it has to be abstracted. I remember the Reddit profile picture launch, where it had about 7 million users buying and selling Web3 enabled profile pictures. It was all of the complexity was abstracted away from the end user. And I think that's where this is all going.
Yeah, except a lot of those other solutions were still centralized solution. So you're going back. And we see the downside of centralized solution. Remember the DeFi craze was it 2021? This is when the Celsius, the Voyagers of the world come in and say, we're going to simplify your DeFi experience. We'll give you a aggregation, a front end where you just put money and magically the yields come in. And turns out they're doing all the unsavory kind of things in behind the scene, and then the whole thing collapsed, right? This is why you don't always just go with the easy solutions. Okay, decentralized technologies are fundamentally less scalable or harder to use, therefore go use a centralized solution, right? This is repeated in this industry. We're seeing this over and over again, right? It's like you design something the architecture has a lot of fundamental limitations, then you layer complexity on top, which usually trade-off, right? It's usually trade-off is, I'll go back to centralization again, or go back to fragmentation again. It's easier to use, or maybe has some benefit, but the trade-off is not, you have to ask a question whether the trade-off is acceptable or not.
Makes sense. And in addition, or on top of ZK Login, you've also launched the Kiosk product. What does that do? What's the idea?
Yeah, this is another example when you think about it. For developers, for builder, if you're creating some kind of asset, you want to have a say in how your assets are being used, being consumed, or being resold, right? You're probably familiar, right? You say if you go to some of the luxury store, they sometimes limit you what you can do, or luxury cars, right? You're not allowed to, or watches, you're not allowed to resell them on the secondary market, that they block you, right? So there's rules around assets, including resale. And you're seeing the NFT back in, again, 2021, 22, seems like eternity ago, right? There was this kind of bubble about NFT. Everybody's buying PFPs, and the idea behind it is great, right? It's so easy for a creator to create some asset using the online marketplace to resell, and they will benefit from all the resell, secondary sale royalty, and all that great stuff. Guess what, right? The chain or the smart contract were not able to enforce the rules around royalty payment. It will go back to centralization. Marketplace, which is controlled by human, say, I'm going to honor the secondary royalty payment. Guess what happens when you let human do enforcement of rules? Well, ultimately profit. What's most important to them is what they're going to do. So then Blur came in, they say, forget about, right, royalty, which is going to like increase volume, which is good for them. And then OpenSea's were forced to follow suit, and the whole thing collapsed because it becomes nothing more than just trading vehicles. It's mint coins with JPEGs only. So this is wrong, right? Again, like we took a step forward and then took 2 steps back, right? Because now you have a system that don't have a way to enforce the laws the creator are laying down, right? In the non-Web3 world, you can say, I will sue you if your gallery don't pay me my royalty payment. You can't do that in this world. It's actually worse than the previous solution because you go back to relying on centralized entity. So this is a solution to that. How do you build a permission asset on top of permissionless infrastructure where the rules are built in to the asset? In this case, kiosk is a way you can think about you setting out your own shop. You put your asset in the kiosk and then guarantee the rules you lay down for transfer always honored by software. There's no way that human can come in and interfere with that. Royalty payment could be one, but you need a third-party witness to sign off. You need Tom to tweet, I'm buying this thing before this transfer can go through. You can define what are the rules you want it to be. And that's the idea behind it. That's one of the many solutions, the other solution we have around this idea. Like you want to embed the rules around the asset and not allow centralized entities or human to enforce rules.
There's a reason we call it a smart contract, right? It's basically law or policies or rules that are encoded in the execution of transactions around an asset, right?
Yeah.
I think this idea that I can determine it at creation time and then the rules are immutable and then enforced through makes a lot of sense. I think particularly I was talking to a crypto investor yesterday who's really keen on real world assets. So actually moving a lot of whatever it's mortgages or car titles or even securities on chain, we will need these kinds of strictures, these kinds of rules and these kinds of computational guarantees in order to make sure any of those kinds of transactions work.
Yeah, and frankly, the blockchain before SUI failed at that. If you think about, you're probably familiar with again, I'm going back to the NFT example, C721. You're encoding very little information on chain. And because anytime with that model, anytime you have to encode all the additional information on chain, you have to have come to some kind of agreement among the community members on ERC, new standard, and everybody's needs are different, right? So it's a very permission way of getting consensus, social consensus to adopt a new protocol, so to speak, or new standard. And they're fundamentally unable to encode these kind of rules or information on chain because on-chain storage is nobody else can scale on-chain storage. So you end up with these tokens or whatever you want to call them, basically at best certificate of ownership, where all the important information that's required to understand the underlying properties, the rules around the asset are actually off-chain. So we can talk about real-world assets, right? But if your on-chain representation is ownership of the underlying asset, there's very little you can do with it other than fractionalizing, transferring them. Even that can be limited because who's going to enforce KYC, ML checks? A lot of these things, right? So again, we're learning through our experience.
You said something really interesting in there, which is everyone else's on-chain storage is limited. Can you expand a bit on that? Why is that important, and how does Mysten solve that challenge?
So yeah, actually, this is a problem we ran into when we at Libra, when we try to do something equivalent to what we call money order. Imagine a government issue 1 million money order and transfer to the citizens and sitting there waiting for them to cash out. So turns out there's a limit, right? There's how many outstanding these kind of money order can store on chain. And that's when we realize, oh, when we talk about scalability, this is another category of problem that you need to solve, which is on-chain storage. And to really solve the on-chain storage problem, you need to understand why first it's so expensive in the first place. Blockchain, by the nature of what it is, there's replication. How many validators there are in a typical environment, you're going to have that replication. There's nothing you can do about that. But even that, the overhead is far worse than that. It's because everything is stored in these authenticated data structure, or Merkle trees, or other kind of tree type of data structure. And then you ask the question, why are these kind of information about the underlying assets stored there? Authenticated data structure should only be there to store the transaction record, or something allow you to go back and verify your transaction was correct. You don't need to store to have all these overhead for the states. So then we realized when we designed SUI, this is a big problem we need to solve. We need to come up with a very different data model where you don't have this unnecessary overhead. Like when people ask us about SUI, what's the difference? They all talk about the scalability and the Move programming language. Actually, the magic is in the data model. The data model means fundamentally, if I want to describe it somewhat easy to understand ways, think about all the other blockchains, one giant global state where everything's mixed together. And for SUI, because it's a sea of objects, right? Every asset is self-encapsulated object with all the states in there, that you can have this encapsulation kind of separation that allow you to scale on-chain storage in a conventional means. What needs to be stored in authenticated data structure and whatnot. But this led to everything else in terms of programming model, in terms of how we think about congestion control, in terms of how we think about parallelizing not just transaction execution, but the entire pipeline. All that actually come from the understanding the data model is a fundamental problem with the blockchains before.
Makes sense. That makes a lot of sense. And so what you're trying to do, at least the way I understand it, is you're taking basically the minimum viable data that you need to be encoded in a Merkle tree or some other cryptographic form, and then everything else that might be associated with a transaction or with an object is stored somewhere else. And that's what gives that scalability.
Right. Yeah, but that require you to separate out from this giant tree of states to each one are basics, each asset being separate.
How big for a given object? Let's say I don't know, creating a new NFT, suppose. How much data can I actually store within an object?
I forgot the exact limitations right now. I have to look up the number. I think it's maybe a meg or 1 megabyte or something smaller than that. But the power of the SUI model is you essentially can embed. It's hierarchical, right? So if you think about everything in the world are actually hierarchical, right? So I'm having this glass. You can think of this as two objects. Right, there's the water and there's the glass. So this is a glass is almost like you can think about parent, and the glass is the water is embedded in that, right? So you can basically decompose an asset into as many parts as you want, and this allow you to change only parts of the overall asset, and you allow you to do another thing that crypto people like to talk about is composability, but they're only talking about code composability. This is data composability or asset composability, which maps to the real world much better, or real world or non-Web3 world, right? Even in gaming, in anything that's hierarchical, maps much more seamlessly.
One of the topics that you talk about, which has origins within the Web2 world, if we call it that, is the DAG, right? Just building on this idea of data composability. You're the only going through your documentation. I haven't read every blockchain's documentation, but you're one of the few, if not the only one, that talks about a DAG, which is a directed acyclic graph, which goes to this sort of composability. How do I put together a data product or an object as a function of all these different upstream dynamics? Does the DAG relate to the distributed storage and this idea of composability, or are they separate?
No, that's separate, right? I think about DAG, you mostly talk about the internal, the consensus, and the consensus mechanism and how to use DAG internally. My co-founder, George Danesis, right, our chief scientist, he was the pioneer here back in the days. DAG mania, this is several generations before, right? Already using this new data structure to build more scalable consensus protocol.
That makes sense. So maybe we can talk a little bit about the ecosystem. You built a phenomenal ecosystem around the company. Some of the initial sort of applications, gaming was one. I remember maybe 6 months ago, internally, we published this research around like the cost per transaction of other chains compared to SUI. SUI is very much at the bottom. You're talking about fractions of a penny. And in order to enable microtransactions, a blockchain like SUI is perfect. Can you talk just a bit about who's building on SUI? What's really drawing them to the ecosystem today?
When we talk about developer, we look at them in two categories. There's the startups, right? There's the visual entrepreneur, people enthusiasts, there's crypto native builder, they build a lot of this. So the more protocol level product, DeFi or NFT collections, and even on-chain betting or all these kind of primitive type of product, crypto native product. And that's growing tremendously. We have like DeFi quicker to market, quicker to accelerate because it's just something the sort of the DGNs are very familiar with. And so that grew that very quickly. And the developer came and they realized, hey, we can make more money on building on SUI, or we can build better product on SUI. A combination of both led to a lot of the inbounds from the developer community, from all chains or new developers. We had some like tremendous success stories there already. Gaming and other kind of consumer product is more of a harder to tell from the outside. We have a huge pipeline of games, probably somewhere in the 70, 80 by now. Gaming just take longer. I think this iteration of game builders, the profile quite different from the first wave. These are more game developer adopting Web3 technology rather than crypto people trying to make games. And there's still both exist, but there's more shift to that. And there's more AA, AAA games. They typically take some time to come, right? AAA games can sometimes take 5+ years to come to the market. But this year, we're going to see them launching. We're going to see some big titles launching basically continuously through probably Q2 to it just throughout. And finally, the pipeline is full and development are coming to close. So we're super excited about that. Gaming is going to be a big thing because once again, game industries, along with some other sin type of industries, are always the first to adopt new technology, and they're starting to adopt their business model around it. And that's exciting. They start to adopt more clever and more kind of a game loops around the concept of ownership. And that's exciting because what we saw in the first wave were mostly gamifying some work, which is great, but it's not really game people play for the enjoyment. And this wave is going to be quite different. And the quality, the team, everything is just continue to increase. Super excited about that. And there's going to be other consumer type of products and financial products beyond just DeFi, NFT are coming. It is an active ecosystem. We're seeing a clear kind of a upmarket movement, a more bigger, more established company are coming to SUI and build because like now we're coming close to 1 year. The words are getting out. People are understanding what this is all about, why they want to work with us. Our reputation is great in terms of how we work with our partners as well. So all that is like we're seeing this kind of hockey stick growth are happening and the cranking the flywheel going faster and faster. Super exciting time.
That's great. We've talked about the technology. We've talked about some of the products you've built on top in the ecosystem. Maybe to close it out, let's talk a little bit about the token launch. You've had a phenomenally successful token launch, brought some unique ideas. How did you think about it? What are some of the thoughts that went into rolling out the token the way that you did?
We think about, this is something people ask about. Outside the space ask us all the time, what is the business model? If you think about launching a token or building a blockchain, it's like building a blockchain is almost like in the old world, you're you have a plot of land in California, and the investor give you some money. Is I'm going to build a railroad, and then we're going to grow a town around it, and everybody owns parts of that enterprise, and you see hopefully the value grows over time and all that, right? So and this is going to be a community effort. Right, but you do have some skin in the game. So token launch is an important part of that because it reflects the needs for utilizing these utility to access all that. And to us, right, that means it's very important for us there has to be finite supply, because ultimately this needs to be a sustainable ecosystem. It cannot continue to be subsidized by inflation, essentially, which is the common practice of most of the proof of stake systems out there. But we took the stance that we basically give us our timelines. Like this is going to be this like community effort, decentralized effort, and we all going to share success. Therefore, it needs to be self-sustainable. You need to attract enough economic activities on there. Otherwise, it's not going to be a successful endeavor. So that's very important, right? That's the main thing that we did that's very different from everyone else. There's fixed supply, no inflation whatsoever. So a lot of other things were somewhat different because it's regulation is never clear in this space. So we were just basically staying on the right side of the line, even in the somewhat some murky state of regulation. We're taking the route of doing what's right for everyone involved. Yeah, it was not easy. It's a lot of complication, a lot of thought going into that. Perhaps let me touch on another thing that's very unique. Right, people often confuse tokenomics with sort of the emission schedule, and that's it. What tokenomics, the most important part, one aspect of the important part is, if you think about economic kind of development, you want to, and what the user of the chain needs is they want predictability, right? So we don't talk about fees in terms of artificially suppressing the fee, because people who are in the business running the network need to make money as well. You need to give them a way to make money. So how do we do that? It comes down to this self-balancing mechanism where the builder say, this is going to be the price, because at this price and this level of activity, we know we can at least break even. And if we keep it low and the traffic goes above that, we make more money anyway. But this also provide a predictability to user, right? You don't want, the last thing you want is, so this is another thing, right? So if you think about this as a way for people to, infrastructure for product builder to build services that build a business on top of it, they need to know how much they're going to spend. If you have external events such as somebody doing an airdrop that somehow influence my cost of doing business, that's not acceptable, right? Imagine AWS jack up your price because someone else consume all the bandwidth they have. That's just not acceptable, right? So we have this sort of self-balancing auction model to keep the fee predictable and stable. So it's not artificially depressed because subsidy. It's there because you find this balance of one side making enough money, the consumer side has the predictability of what they need to spend.
It's wonderful. I want to thank you very much for spending the time with us today and sharing the story. Like I said at the beginning, I think you're one of the most impressive founders in terms of solving very difficult technical problems. And here, there's both, and we talked about it, there's the language, or the advantages of the Move language. There's the simplifying the user experience in order to maximize onboarding yield, and then ensuring that as more and more assets and billions, if not trillions of value start to move onto the blockchain, that they're treated the right way, both in terms of secure transactions, but also the original rules that the creator intended apply. And then the very last part is what you just touched on right now, which is the thoughtfulness that goes into the token supply, both capping the total amount of tokens in order to make sure that the ecosystem is healthy, and then balancing costs, particularly when you have surges in usage. So I really want to thank you for the time. We're grateful to have you on Office Hours.
Thank you for having me. It's great. It's a pleasure.